Right, conjugate theorems. Okay, so we've already looked at the conjugate for a complex number. So we have a complex number z x plus yi. Okay, where of course x and y are real numbers. Okay, then we have the complex number, the complex conjugate. So we notate that with a hat above z. Okay, and we change the sign between the real and the imaginary part. Okay, and that's what's called the complex conjugate. So, the following theorems are useful. So, the box on page 49, 45, sorry, in your notes. Towards the bottom, there are 7 properties there. Okay? So, if I want to add or subtract all the complex numbers and then find the conjugate, okay, I can find the conjugate of each individual complex number and then add or subtract them together. Okay? Same with multiplying. If I multiply a whole bunch of complex numbers, then take the conjugate of that complex number. Okay? If I write down the conjugates of each of those numbers and multiply them together, I will get the same answer. Okay, division as well. So if I do z1 divided by z2, then take the conjugate, it will equal the conjugate of the numerator and the denominator that we write down first, and then work through to get the same answer. Now, z times its conjugate will become x squared plus y squared. Remember, x's and y's come from the real imaginary part of your complex number. You do the addition of a complex number and its conjugate, we will get 2 times the real part of that number. If you do a subtraction of z and its conjugate, we will get 2 times the imaginary part of a complex number. We want to take the reciprocal of a complex number. It's the same as multiplying with the conjugate on top and z times z, z bar on the bottom to get through, because number 7, 1 over z is z. So sorry, if I multiply each of those by its conjugate, okay, so we've of course got z bar over z bar. Okay, so that's why that works. Okay, and then from that earlier theorem, this part is equal to x squared plus y squared. Okay, so a couple of useful things to know. Alright, so let's do some examples to fulfill those. Alright, so complex number 1 is equal to 3, take away 5i, and complex number 2 is equal to minus 2 plus 2i. So remember, the real and imaginary part can still be part of the real number system. Okay, so I can still have fraction, decimal, okay, any other expressions. I can have surds there technically if I want as the real and imaginary part. Okay, I just can't have a complex part as part of the complex number, okay, in there. So it'll always be a real part. Alright, let's find the following. A, so z1 plus z2, and find its conjugate. So of course you can go ahead and add z1 and z2 together and then write down the conjugate from that, or using the theorem, okay, this equals to the conjugate of z1 plus the conjugate of z2. Okay, so you can do it this way as well. So it equals 3 plus 5i plus negative 2 take away 2i. So when you take the conjugate of a complex number, the real part will stay the same with the sign as well. The complex number will stay the same number, the imaginary part will stay the same number, but the sign will be reversed. 3 take away 2, which is 1, 5 take away 2, which is positive 3. Okay, so again, if we add them, 3 take away 2, which is 1, negative 5 plus 2, which is negative 3. So we have 1 take away 3i. Then we take the conjugate. We just change the sign in there. Okay, so there's no real benefit of doing that. It just might help you with some other questions down the track. B. Z1 conjugate. Okay, so you can set it up to a FOIL, expand the FOIL out, which will become the difference of 2 squares. Okay, expanding. Okay, or if you use the rule, it's the real part squared plus the imaginary part squared. So it will become purely a real number. Okay, there'll be no imaginary part to it. So Z1 is 3 take away 5i, so it'll be 3 squared plus negative 5 squared. Okay, so 25 and 9, which is 34. Okay, so you can set it up to a FOIL, expand, simplify. You'll find your imaginary part will cancel out, okay, because you'll be subtracting something or adding something that will make it all disappear. C, Z2 take away Z2, the conjugate of Z2. Okay, so you can set it up, you can write down negative 2 plus 2i, take away in bracket, negative 2 take away 2i, and do that arithmetic, or use your result to times the imaginary part, and then you need to put the imaginary symbol on it. Okay, so remember, we are not taking I as part of your imaginary part, just the number with I, but not I itself. Okay, so Z2, Y is just 2, not 2Y, just 2. So it'll be 2 times 2. And the reason why Y is there, because it's going to be part of your formula. Okay? So if you set it up to do the arithmetic, that way you will get the same answer. Last one for today, 1 over Z2. So we're going to take the reciprocal of Z2. Okay, so it'll become a Z2 hat over Z2 as a result of your law there. Sorry, Z2 hat. Okay, so we've looked at an example where Z times its conjugate is equal to X squared plus Y squared. And then the conjugate of negative 2 plus 2i is negative 2 take away 2i over actually, yes, I didn't need it. So Z2 X squared and Y squared. So it'll be negative 2 squared plus 2 squared. 4 plus 4 is 8. Okay, and then split up your fraction. Okay, because you need to have each complex number represented with a real part and an imaginary part. Okay. Any questions?
Nope. Yeah. For now.
It'd be nice if we could get through a whole page each lesson.
Yeah.
Doesn't matter.
They're not so intimidating. I'm slightly disappointed.